Okay, today what we're looking at is word questions. And it's a little bit different than our first unit, which you didn't particularly like. So our goal is I can translate word questions into direct and indirect variation equations, and I can solve for unknowns. Okay, so we know that we're making direct and indirect variation equations, so we have been doing that. So it's not too much different. It's just focusing a little bit more on word questions. Now, there's a few steps there. First of all, you read the question. Don't worry is after the first read through whether you get everything that you need from that. Okay, so you should always read it more than once. I do, so I would expect that you would too. Okay, then we need to define our variables by making let statements. Now, what's different here with the let statements is the variables, we're going to just, instead of calling them x's and y's, we're going to choose letters that best represent what we're talking about in the question. So if we're talking about cost and products made, so cost, probably I would say let C represent cost. Okay, so it's not the same kind of let statements as we did in our first unit. And also in some cases, we don't have to make let statements because the question has the let statement right in it. Okay. The next thing we need to translate the operational words. Now the operational words are things like plus, minus, it could be multiplying, it could even be dividing. Okay, so we're going to translate that over top of the question because that's usually the best way in order to be successful. Then we're going to write our equations, and that means that we're going to have to read the question again. So we're actually reading the question one time. We're translating operational words, which means we've looked at the question the second time, and then writing our equations, we're actually looking at that question the third time. So don't think that you can just read it once and automatically be able to do everything. Okay, so let's look at a few of these types of questions. So the first one is the Mitchell Advocate has a deal for classified ads. It charges $15 a week and 5 cents a word. And then it says create an equation to represent the cost in relation to the number of words. Okay, so what's going on here? So we're talking about write an equation to represent the cost. So obviously I'm going to need a variable to represent the cost, and it even uses the word represent. So if we're going to do that, it makes sense, cost, maybe the letter C. So let's do let C represent the cost. Now, what is our other variable here that they are expecting us to talk about? So we're talking about cost, and it's in relation to the number of words. Okay, so words are involved in this. So I'm going to let, I think W represent the number of words. So let W represent the number of, oops, sorry about that, ran out of room, number of words. Okay, so if I look back at my steps, I've read the question once. We've actually gone back to the question to figure out what we're going to use for our let statement. Now we need to somehow go back and check to see the operations. So it says it charges 15 cents, $15 a week and 5 cents a word. Okay, so the word and here. What operation are we talking about? Well, I think we're talking about adding. So in 1 week, I would charge $15 plus 5 cents for every word. So I just translate it. So let's break that down. So the cost is going to equal the $15 plus 5 cents. And I think I'm going to put it as decimal 0.5 times the number of words. Okay. Now it says per week. We could have actually came up with another equation too if we were going to do it for more than 1 week. But in most cases, we're just going to do it for 1 week, our ad. Now the reason companies have this $15 a week plus five cents per word is there's like a setup fee to set up the ad, and it costs you 5 cents per word. So yeah, you're saying one word and it's going to cost me a $15.05. Yep, that's what it's going to cost you. So let's go on to the next part of the question. It says, using your equation, determine how much a 40-word ad would cost. All right, so the first thing I noticed, it says using your equation. Okay, you maybe can do that in your head. That's supposed to be a line, and you can see it's not a line. If you don't use the equation and they tell you to, in some cases, the person won't even mark it. Okay, it says using your equation. So because it says using your equation, I'm going to write down the equation that we made. Okay, now it doesn't matter whether I have the 15 first or whether I have it second, but I'm going to copy it down the way that we have here. Okay, so you can see all we've done is we recopied it, and now it says determine how much a 40-word ad would cost. Well, words stand for the letter W, so where there is W in our equation, we're just going to substitute that 40 into it. So let's continue on. So we have, as soon as my pen goes where I want it to go, it goes 15 plus 0.05, and this is times 40, which is 15 plus, and if you cannot do the 0.05 times 40, then you're going to take out your calculator. But I believe it equals another $2. You don't have to put the zeros there. So a grand total of 17. So word question, so I need to put a therefore statement. Therefore, the ad would cost $17. So this is where I'm putting my units. And there are no cents, but you can put 00 if you so wish. Okay, so let's go on to the next question. Okay, the next question is Colin is having a party. He books the arena, should say arena, not area. So we need an A there. Arena for $400. The caterer will charge $19 per person. Write an equation where C is the cost and P is the number of people. Okay, so let statements. Well, I really don't have to do a let statement for this one because it says C is the cost and P is the number of people. Okay, so they already have defined the variables that they want us to use. And a lot of questions do that. So let's take a look then. So back to see what we have. So Colin is having a party. He books the arena for $400, whether he has anyone invited or not, and hopefully he invites us all. The caterer will charge $19 per person. Okay, so obviously this 19 is going to be 19 times P. And our cost is going to be, are we going to add the 19 to the 400? I think that's what we probably should do, right? Because the cost is the initial cost of the arena of $400, and it's going to cost Colin $19 for every person. Okay, so if he invites 10 people, it's going to cost him $590 to have them all. Now it says how many people can he invite if he has $1,200. So where does the $1,200 go? I mean, obviously we could guess and check, but we don't need to do that. We know that is 1200 is the cost. That's the as high as he can go for his cost. So we can actually take our equation and substitute in the 1200 for the cost and then solve for the number of people, okay, the variable p. So we're going to put 1200 here, and if you notice, we're solving a lot of equations, even though we're not in the typically in the algebra unit. All right, so first thing we need to do is get p by itself. So we're going to subtract 400 from both sides. And when we do that, we get 800 equals 19p. And then we need to divide both sides by 19. Now, it's not going to go evenly, and that's all right. So we need to bring up a calculator. And that's what I've done here. I just brought up this one instead of the graphing one. So I'm going to enter my 800, and I'm going to divide it by 19. And when we do that, we see that we end up with 42.1. So obviously we can't have zero point 0.1 of a person. And so even if I had 0.6, he still wouldn't have enough money for 43. Okay, so we have to go always round down in this case. So he could invite 42 people. The next question says, how much money would he have left over? Well, I'm going to use my equation if I want. So I know that the cost is going to be $400 plus 19 times 42, because we have 42 people. And when we actually take our calculator and calculate that, so we have 19 times our 42 guests plus our 400, so 1198. So leftover, obviously he's going to have $2 left over, because if we subtract it in our head, we would have 2,000. Take away the 1198 for $2. So he would have $2 left over. And our final question that we're going to look at in this session, oh, actually second final, Jane has a part-time job that pays $32 per hour. Write an equation that represents her wages. This one's a lot shorter than the other ones. Okay, so obviously they don't have any let statements. So we're talking about wages. So maybe we'll use P for pay, and it's dependent on hours. So maybe H for hours. Okay, so if you notice, I'm just making up the letters I'm going to use, but I have to tell people what they are. So let W represent wages. P would have been okay too. And H, the number of hours. And when we substitute that in, so we have our wages is equal to 32 times H. And we're finished. That one's been done. Okay, so we have one more, and I ran out of time, so we're gonna have to stop, and I'll pick up the next video.